Okay, we're going to be talking about in this video properties of complex conjugates. Okay, um, complex conjugates being conjugates when we're talking about complex numbers. Okay, so if I have z is a complex number defined as a plus bi, where a and b are real numbers, we have a real part and an imaginary part. This complex number has the conjugate z star, and this is how we're going to notate the conjugate. Some textbooks you might see as a z bar, okay, but just for our purposes we'll be using the z star notation. Okay, so this becomes, if z is a plus bi, z star, the conjugate, is a minus bi. We know this from Algebra 2 and from pre-calculus, right? So now let's look at some of the properties of this star. What happens when we do perform some operations, okay? If I were to take the conjugate of a number, or of a complex number, and then conjugate it again, okay, we would get z. We would just get back, we would come back to the original number that we had. If I have z1 plus z2, the sum of two complex numbers, okay, and then I conjugate that, you will see, and I'm just going to give these rules here to you, and your assignment will probably be to prove these, but I'll just give these to you. z1 plus z2, if I conjugate that, so if I take this plus maybe c plus di, that actually turns out to be the conjugate of each of those terms, and then the plus sign stays the same. So you can think of this as distributing the, okay, it's slightly different, but from regular algebra or arithmetic, you can think of this as distributing across the operation. Okay, so likewise with a difference of two complex numbers, you could have z1 star minus z2 star. The same goes for multiplication. z1 star, z2 star times z2 star is the result of this. If I have the quotient of two complex numbers and I conjugate that, then I end up with z1. That would be the same as z1 star over z2 star. Okay, provided that z2 star is not 0. Okay, z2 or z2 star, I should say. Okay. So you can see here that, think of this as, a nice way to remember this is thinking of this as the conjugation, okay, conjugate kind of distributes, okay, across the arithmetic operations, plus, minus, multiply, and divide. So it kind of distributes across these operations. Okay, when I have z to the nth power, if I have this number raised to the nth power, so I multiply this number n number of times by itself, and then I conjugate all of those, I could simplify that as taking the conjugate of this, the conjugate, and raising that to the nth power. Okay, so these are just some of the properties, okay, and we will prove these in the assignment. Z plus z star, okay, if I add the complex number with its conjugate, what do you think will happen here? This part and this part will cancel out, so I end up with just a plus a. Okay, so this actually is a real number. We can just generalize that as becoming a real number. Okay, and it's likewise if I take this times this, because this really is a the product of it would actually become the difference of two squares. Okay, if I did FOIL here, and so this would also be a real number. Okay, so you can think of this as not the imaginary parts. Really, what's happening is the imaginary parts would disappear. Okay, disappear. Okay, so these are the properties of complex conjugates. You do need to know all of these and be very familiar with them, because we will be doing proofs with these properties.